Okay, so this is just a short class on scales of measurement in statistics. So you would need to identify variables and know what scale these variables are being measured. What is a variable? What is a variable? A variable is any characteristic, measurable characteristic that has the ability to change value from one unit of the population to the other. Any measurable characteristic that has the ability to change value from one unit of analysis or unit of the population to the other. So for example, sex is a variable because sex can be male in one person and female in another person and male in the other person and female in another person and so on and so forth. Weight is also a variable because weight can take up a different value from one person to the other. Same thing with height, same thing with temperature, same thing with blood pressure. Most biological characteristics have variability. So between one unit of analysis, one individual, one population, one unit of the population or the other, they change. The reason why I'm explaining variables is that you need to understand what a variable is first before you talk about scales of measurement of variables. How do you measure variables? So 4 major ways of measuring variables. And these 4 ways of measuring variables lead to categorization of variables in 2 categories. Number 1 way of measuring variables is that you have some variables that in of themselves are measured on a nominal scale. Nominal means by name only. By name only. For example, sex, treatment type, blood group. All right, by name only. So you can have the ones that are just 2 categories, options are possible. Only 2 categories are possible. They are called dichotomous variables. Only 2 categories. There are some that I have 3 or more categories, like blood group. Yeah, they are called categorical. Categorical is a general name. A special type of categorical is dichotomous. What type of analysis can you do with nominal variables, which is like by name only? They don't really tell you anything about relationship between one group or the other. They just say male. And even if you put numerical values, like I said, and in coding, when you want to code, you could give numerical values. Male will be 1, female will be 2. It doesn't really mean that 2 is higher than 1 or 2 is better than 1 or 2 is any way different from 1. It's just by name only. What do you do? What type of measurements can you do with nominal scale measurements? It is frequency and proportions. That is the type of summary statistics you get. It's frequency and proportions. So for example, how do you summarize the sex of people in this class? You say 5 people were males and 10 were females, which means that X percentage were males and Y percentage were females. And that's the best you can do. With ordinal scales, there is a name, a nomenclature, a name given to the various values of a variable. But in addition to a name given to them, there is some level of ranking, some order in which these variables appear. So for example, disease severity, mild, moderate, severe, BMI categories, underweight, normal weight, overweight, obese, blood pressure categories, normal blood pressure, elevated blood pressure, type 1 diabetes, type 2, type 1 hypertension, type 1, type 2, type 3, there's still anything like that. So you see the grading. Medical house officer, medical officer, registrar, senior registrar, consultant, professor, like that. There's a ranking. So you know that one is on a higher rank than the other, but you don't have a numerical value for what separates one rank from the other. You do not have a numerical value for what separates one rank from the other. You know that one ranks higher. Likert scale, for example, is a typical ordinal scale. Likert. Three scale Likert or 5 scale Likert, like Professor Best was talking to us about. Assume it's a 5 scale Likert. You know that very strongly agree is on a higher level than agree. But by how much? Can you give it a numerical value? No. For most of the time, we would give numerical values to the 5 scale Likert and say 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4. Simply for the sake of analysis, simply for the sake of coding or for making sense, or even to show that there's an order and one is higher in order than the other. But by how much? you don't know, and you really can't find out numerically. How do you analyze ordinal scale variables? What measures of summary? What summary measures do you use? It's the same as nominal. You would use frequency and proportions or percentages. That is the same thing you would do, frequency and percentages. Whole numbers and proportions is how you would summarize. How do you present the data when you've summarized it for nominal or ordinal scale? What's the best way of presenting? You can do tables, and those tables are called frequency tables. Or you can do charts. So pie charts, if it is 2 categories, 3 categories, 4 categories. When it starts getting to 5, 6 categories, a pie chart is no longer the best. You may want to use a bar chart. You will want to use a frequency polygon. You will want to use a histogram. There's so many different charts that you can use for nominal and ordinal scale. Not even a histogram, sorry, a bar chart, not a histogram. Histogram is better for continuous variables, please. I'm making that correction. All right, that's fine. Then the next two, very important, interval and ratio scale. All right, so interval and ratio scale. With interval, there's ranking, there's name, there's rank, and then there is an attribute of by how much more and by how much less. So you can actually do subtractions and additions. So for example, this temperature measured in degrees centigrade or degrees Fahrenheit, not Kelvin. Temperature measured in degrees centigrade or degrees Fahrenheit. If you walk into a room and it's 16 degrees, and you come out, the bedroom is 16 degrees, the parlor is 19 degrees, you can say the parlor is 3 degrees warmer than the bedroom. And you'll be very correct because there's a numerical value to the difference between one temperature and the other. However, you cannot say if the temperature in the room is 16 and the temperature in the parlor is 32, you will not be correct, even though people say it centigrade, you will not be correct exactly to say the parlor is twice as hot as the room. Why? Centigrade or Fahrenheit don't give you true zero values. Please, you can go back and read it, check it up. They don't give you truth because a 0 degree centigrade is not the absence of heat. It's just what you are able to measure. It is Kelvin scale of measurement that gives you an absolute or a true zero. And then when that takes us to ratio scale, and they are analyzed the same way because they are both continuous variables. I'll talk about that in a bit. Ratio scale, values, it has name, it has values, it has ranking, and there's a true zero, which means that multiplication and division is possible. So things like weight, height, age, they are all ratio scale values because you can talk about somebody being twice as heavy, you can talk about the blood pressure being twice as high, you can talk about the temperature in Kelvin being twice as high or twice or the temperature here being half what it is there. And you can do that. What type of analysis? Measures of central tendency for interval and ratio scale. Measures of central tendency are measures of, of course, summary measures rather, for interval and ratio scale, and measures of central tendency and measures of dispersion. So this is where you can do mean, mode, median. This is where you can do histograms. This is where you can actually do standard deviation, interquartile range, percentiles, and so on and so forth. So you can do all of that. So if, for example, your objective is want to compare the weight of one group with the other, immediately you know that the type of analysis that you're going to do is mean or median. That's what you're going to do with standard deviation or interquartile range. That is exactly what you would need to do. And so you will not be seeing any table that has frequency and percentage for an objective where the outcome variable, the main variable there is weight. The same way you will not be seeing mean and standard deviation where the outcome variable is perception of something, good perception, poor perception, or even if you want to rank the perception and say strongly, like at it, it cannot take up main, mode, median. It has to be frequency and percentages. So that is why I said what I said. You must understand the variable or know the scale of measurement of that variable when you are setting up your data analysis table or your data analysis plan. All right.